In this video, I will be discussing implicit differentiation, and we have to take note that the derivative of y is y prime, and for us to derive this, we have to, of course, take note of all the derivative formula that we had, because in this discussion, y is not isolated, or the given function is not equated to y. Now, to do implicit differentiation, I will be using the suggested procedure. Number one is to derive the given equation or function using the different formula that we had from our past discussion. And afterwards, we have to isolate or solve for y prime. So we start with example number one. We have to derive 2x squared minus y plus pi is equal to 0. In this example, we will be using the derivative of sum and difference. So the derivative of 2x squared is 4x. And the derivative of y, as we know, that the derivative of y is y prime. So we have to change it into y prime. Plus the derivative of pi, which is a constant, is 0, equal to 0. Then, in our basic procedure after deriving, we have to isolate y prime. So in this case, we have to isolate y prime. It will become 4x is equal minus y prime is equal to 0. Using commutative property of equality by addition, y prime may be written on the right side of the equation. That's going to be positive y prime. And that therefore, y prime is equal to 4x. For our third example, we are going to determine the second derivative of 2y minus ln x is equal to 0. We know that the second derivative is the derivative of the first derivative. Therefore, we have to take first the first derivative of 2y minus ln x is equal to 0. Using implicit differentiation, 2y is going to be 2y. Let me rewrite it here. The derivative of 2y is 2y prime minus the derivative of ln x is 1 over x, that is equal to 0. As we isolate y prime, it will become 2y prime. We use commutative property of equality by addition, and negative 1 over x will be written on the right side of the equation with positive sign. And then, so this is y prime. And then we have, as we isolate y prime again, we have to remove 2 there. So we have to use commutative property of equality by multiplication. We have to multiply both sides of the equation by 1/2. So this is going to be 1. 1 times y prime is y prime. That is going to be equal to 1 over 2x. Multiplying the numerators and denominators will give us 1 over 2x. So that's the first derivative. In order to take the second derivative, we have to use the derivative of a product, the quotient. So we have to set our u and v and use the formula y prime is equal to v du minus u dv over v squared. So as we do this, it will become y prime equal to v is 2x, derivative of 1 is 0, minus u is 1, derivative of v is 2, over 2x squared. As we simplify this, it will become y prime equal to, this is 0, 0 minus 2 over 4x squared, or this is equal to negative 2 over 4x squared. As we continue to simplify this, our y prime is negative 1 over 2x squared. In this example, which is number 4, we are going to determine the equation of the tangent line and of the normal line of the given equation or function that is 2x minus 3y raised to 2 and equal to 8x plus pi at the point of tangency that is negative 1 and negative 1. To do this, we have to use the general power rule. On the left side of the equation, it will become 2 times 2x minus 3y. You subtract 1 from the exponent, it will become 1. And derive what is inside the quantity, that is going to be 2 minus 3y prime equal to 8. Now as we can see, the left side of the equation are in the form of factors. We can already reduce it by multiplying 1/2 to both sides of the equation. Thus the new line of solution will become, so this is cancel, and this is going to be 4. 2x minus 3y times 2 minus 3y prime equal to 4. Now the left side can be expanded using FOIL method. The product or the expanded form will become 4x. So for the outer, we have negative 6xy prime. And inside, we have negative 6y. And the last terms will be positive 9y prime. That is equal to 4. So this is negative 6xy prime. Now we have to isolate y prime by grouping them on one side of the equation. So that in this case, let's group it on the left side. So it will become negative 6xy prime plus 9y prime equal to 4 minus 4x. By commutative property of equality, by addition, 4x and negative 6y will be written on the other side with an opposite operation. So as we continue, we have positive 6y. Then we have to factor out y prime in this left side, and will give us negative y prime times negative 6x plus 9y equal to 4 minus 4x plus 6y. And by cross multiplication, negative 6x plus 9y will be written on the denominator of the right side, or that's the same with commutative property of equality by multiplication. So our y prime here will become 4 minus 4x plus 6y over negative 6x plus 9y. So this is the formula of y prime where we could use in order to determine the slope of the tangent line, and then therefore we can now find out the slope of the normal line and the equations of the lines. So at negative 1 and negative 1, the slope of the normal line, tangent line, is equal to the value of the y prime where the coordinate negative 1 and negative 1 is substituted. So this is the same as 4 minus 4 times our x is negative 1, then plus 6, and our y is negative 1. Now the denominator will become negative 6 times, again, negative 1. X is negative 1. And then plus 9 times negative 1. Our y is negative 1. As we solve this and evaluate, our slope of the tangent line will be going to be 4 plus 4 minus 6 over positive 6 minus 9, or that is 8, oh no, that is 2, positive 2 over negative 3. So if our slope of tangent line is 2 over negative 3, then the slope of the normal line is the negative reciprocal of the slope of the tangent line. So negative reciprocal of the tangent line, slope of the tangent line, that is 3 over 2. Based on this basic information of the slope, we can determine the equation of the tangent and of the normal line using that coordinate and the formula of our lines. So we have at point 1 and negative 1 and negative 1. So we have to use m equal to y minus y sub 1 over x minus x sub 1, which is the equation of the line using a point and a slope. That's point slope form. Therefore, for our tangent line, equation of the tangent line is going to be 2/3 of y minus negative 1 over x minus negative 1, or that is the same as 2 over 3 equal to y plus 1 over x plus 1. And then as we cross multiply or use commutative property of equality by multiplication, it will become 2 times x plus 1 is equal to 3 times y plus 1. As we distribute 2 and 3, we have 2x plus 2 equal to 3y plus 3. In this solution, I will be taking the general form of the equation, not the standard form. Therefore, I have to equate this into 0. So we have 2x minus 3y plus 2 minus 3 is equal to 0, or 2x minus 3y minus 1 is equal to 0. So this is the equation of the tangent line. Now for the equation of the normal line, we will be taking a different slope, that is negative 3 over 2. So we have negative 3 over 2 equal to y minus negative 1 over x minus negative 1. And as we simplify the right side of this double negative, the new line of solution is negative 3 over 2 equal to y plus 1 over x plus 1. Then we're going to use the cross multiplication or commutative property of equality by multiplication. So it will give us negative 3x minus 3 equal to 2y plus 2. So I have already distributed 2 and negative 3 inside that binomial. Therefore, equating this to 0, I'm going to move this side to the right side because I would like x to be with positive sign. So this is 0 equal to 3x plus 2y plus 2 plus 3, or that is the same as 3x plus 2y plus 5 is equal to 0. This is now the equation of the normal line. So we have example number 5. We have to find the equation of the tangent and of the normal line also of the given curve 3x squared minus y squared is equal to 12x at coordinate or point of tangency that is 1 and negative 1. So in order to do that, we have to derive first the given function that is 3 times x squared minus y squared raised to 2 is equal to 12x. To derive this implicitly, we have to use a general power rule for our left side, that is 3 times 2 times x squared minus y squared raised to the new exponent that is equal to 1, so we don't write it anymore, and derive what is inside the quantity. So the derivative of x squared is 2x, and the derivative of negative y squared is negative 2y y prime equal to the derivative of 12x is 12. Dissolving 3 times 2 is 6, and times these quantities, that is equal to 12. We can now reduce 6 and 12 by multiplying 1 over 6 both sides of the equation. So this side will become 1 times these two quantities, and this is going to be positive 2. Therefore, the new line of solution is x squared minus y squared times 2x minus 2y y prime equal to 2. So by FOIL method, we can simplify the left side by multiplying the first term, outer, inner, and last terms. So we have 2x cubed, outer is negative 2x squared y prime, inner is negative 2x y squared, and the last terms is positive 2 y cubed y prime equal to positive 2. And then we have to group all the terms with prime, with y prime in one side of the equation, and the remaining terms without y prime is written on the other side. On the remaining side. So we have negative 2x squared y prime plus 2y cubed y prime is equal to 2 minus these terms and plus 2 y squared. So we have 2x cubed plus 2xy squared. As we continue to factor out y prime, we have these y primes. Y prime times negative 2x squared y plus 2y cubed is equal to 2 minus 2x cubed plus 2xy squared. Then we have to divide both sides by this quantity, that is negative 2x squared y plus 2y cubed, and it will give us y prime as 2 minus 2x cubed plus 2xy squared over negative 2x squared y plus 2y cubed. So this is our y prime, where we could use to find the value of the slope of the tangent line and of the normal line. As we continue to find out the slope at this point of tangency 1 and negative 1, we have the slope of the tangent line is equal to our y prime with the substituted values of x and y. So this is 2 minus 2 times x is 1 cubed plus 2 times 1 is x, and y is negative 1 but squared over negative 2, x is 1 square, and y is negative 1 plus 2 times negative 1 but cube. So let's evaluate this. It will become slope of the tangent line is 2 minus 2 times 1 plus 2 times 1 times 1 over, we are evaluating the exponents, negative 2 times 1 times negative 1 plus 2 times negative 1. Then proceed to multiplication. We have we have 2 minus 2 plus 2 over, that's positive 2. Negative 2 times 1 is negative 2 times negative 1 is positive 2 plus negative 2. And so, we have to simplify this. It will become, so this is 0. This is 0. We have the numerator equal to 2 and the denominator is 0. So meaning the line is perpendicular to the ground. The line is perpendicular to the ground. And we could say that the slope of the normal line is the negative reciprocal of the slope of the tangent line. So it will become 0 over 2. If the tangent line is vertical, well, in this case, horizontal, because it's 0. And the other one is undefined, which is a vertical line. So let's find out now the equations of the line given this slopes of the tangent and of the normal line. For our tangent line, we have 2 over 0. And for the normal line, we have 0 or negative 0 over 2. So we will be utilizing that. So this is negative 0 over 2 or 0. At point or coordinate, point of tangency, that is 1 and negative 1. And by using the formula of the point slope form, we can determine the equation of the lines. So for the equation of the tangent line, we have 2 over 0, that is equal to y minus y sub 1 is negative 1 over x minus x sub 1 is 1. So as we simplify this, it will become 2 over 0, that is equal to y plus 1 over x minus 1. And then, as we cross multiply our numerator and denominators, it will give us 2 times x minus 1 equal to 0 times y plus 1. So the right side is 0, and we can simplify the left side as 2x minus 1 equal to 0. So this is now the general equation of the line because it is equated to 0. Now for the equation of the normal line, we have a different slope, that is 0 equal to y minus negative 1 over x minus 1, same coordinate or point of tangency. We have